ABCD is a parallelogram. AB equals 3A, BW equals B. M is a midpoint of CD and AX is twice of XC. BW is to WC equals 1 is to 5. Find BX in terms of A and B and show that BXM are 3 points on a straight line. So the direction, let us do that. AB. So AB would be AB plus BW or BC. So BW would be in this direction. That would mean AC would be in this direction. So we can write AB plus BC. So for part A, we can write AB plus BC equals AC. Now we see that BW we know is B and BW to WC is 1 is to 5. So the BW is 1, WC is 5. So BW out of WC equals 1 out of 5. So from here we get WC equals 5 BW. So here when we say BC, BC can be written as 5B. BC, not B, WC is 5B. So BC, so we write BC equals BW plus WC, and that equals BW is B, and that is 5 times B. So that would be 6B. So BW equals 6B. So we write it neatly. So BW equals 6B. So we got that. Now next we got to find what AC is. Yeah. No, sorry. Sorry, it's not BW, it's BC. What am I writing? BC equals, so I do BC equals 6B. So BC equals 6B, right? So this is done. So BC equals 6B. Now we have to do AB, we know is 3A. So AC would be, we can write here 3A plus 6B equals AC. Now AC equals AX plus XC. We can write AC equals AX plus XC. So AX we know is AX is twice of XC. So we can write that at twice of XC plus XC. So AC equals 3 times XC. Therefore, we can write AC as AC we know. So XC would be 3A. So we can write 3A plus 6B, and that is AC. AC is there. So 3A plus 6B, and then if you are to divide it by 3, you would get XC, or XC equals A plus 2B. So we found XC. Now you see we need to join BXM because of the second part of the equations. If I use a line drawing and say that's the BXM. So BX it's what in terms of the bx would be in that direction. So then, and xc is pointing here. So then what we can write is now bx plus xc, we know what xc is, equals bc. So we can write, now we know what xc is, so we can write bx plus xc equals bc. So bx we have to find, so we can write bx as it is, plus a plus 2b equals 6b. So we can write bx equals 6b minus a minus 2b, and that equals minus a plus 4b. So bx we have got is minus a plus 4b, and that is what the first part is all about. Find bx in terms of a and b. So we've got it, let me write it down. So we got bx equals minus a plus 4b. Now that's done. The second part, a little here, separate here. So the second part is about finding or proving that bxm are in a straight line. So to do that, we need to find xm. When we need to find xm, we have to deal with CD or DC. So you see DC is parallel to AB. So the direction is the same. So if we are to say that's DC, so MC would be half of DC. So DC, we can start with DC equals 3A, and MC equals 3 out of 2A, because MC is half of DC. So we can write MC equals half DC, right? So then once we know MC, then you see XC, because XM would be in this direction, that's this, and that's this. So XM plus MC equals XC. So let's write XM, XM plus MC equals XC. So XM, we need to find that. MC we know, and that equals XC. So we know that as well. So XM plus MC, that is plus 3 out of 2A vector A, equals XC. We have found XC. A plus 2B equals A plus 2B. So XM would equal A minus 3 out of 2A plus 2B, and that equals 2 minus C minus half A plus 2B. And you can write this as half. If you take outside the bracket, you are left with minus A plus 4B. So you see that this half and bx, so we can write that is xm. So xm and bx are scalar multiples of each other. Xm and bx are scalar multiples of each other. So xm is half of bx. We don't need to prove that, but that bxm would probably be in a straight line. So that means bxm would lie in a straight line, because one is a scalar multiple of the other, so they are on the straight line. They're likely to be on the straight line, and xm is half um, of bx. So though we don't have to, they haven't asked for it, but yes, we can say that bxm uh, would probably lie on a straight line. So I think we have done the B part of our proof. That completes it.